to our refinancing problem, and the thing is, does it pay to refinance? That's the question. So let's look at the old loan and the refinance loan. And let's look at your total payout. Well, the old loan, you already sunk money into it. That doesn't count. It's what happens from here on out. But you have 280 periods to go on your old loan if you would have continued with it. And you would have paid in the end $283,080 over those next periods. Now, for the new loan, you pay $904 per month, but you had 300 periods, and that's $271,200. So by refinancing, you would have saved $283,080 minus $271,200. You saved $11,800. Now it's probably worth it to you. You've only gone through 80 periods. It was a 30-year loan. So 80 periods divided by 12, it's almost the same thing. You've got 25 years to go. So what you have to compare is how many periods are left on your old loan and figure out how much you would have paid and how many periods of the finance loan. And here you would have saved $11,800. Okay, so that's the way you calculate a refinance problem. Now, of course, you would probably say, okay, so it's worth it for you to refinance in this case. All right, now there is one on the final, and it's just exactly like this. So let's do another problem now. And let's do an investment problem. I'm looking for one where we have a lottery here. Just give me a minute. Okay. Okay, so number 31 on your worksheet. So you have an IRA. That's what's in your IRA account. At t equals 0. Okay, so what they want to do, they want to supplement their income with payments at the end of each quarter. So M equals 4. They're going to get an interest rate of 12%. Huh. Compounded, well, it says here compounded monthly. No, it's each quarter. So M equals 4. I'm sorry, it's 8%. I'm reading the wrong one.
I think we can still laugh, though.
It's still laugh, right? 8%. And it's 15 years. So what we want to know is how much are they going to get each quarter. So the $780,000 IRA is at t equals 0. That's your present value. In most cases, IRAs, lottery winnings, inherit problems are present value problems. Any one that we're going to look at. So IRAs, lottery winnings, inheritance are present value problems. So what does this say? Payment, let's say at the beginning of each quarter. So this is a present value annuity due. Now notice the problem on your worksheet is not at the beginning of each quarter. I'm changing it a little bit. Number 31. So the formula for an annuity due Alright, it's same as the present value formula for an annuity with a little appendage. So I'm going to put down 780,000. That's a times 0. I got that from another account. I want to find R. Okay. So little r is 0.08. We're doing it quarterly. And that's going to be minus 4. And we're doing it for 15 years. 1 plus 0.08 over 4 divided by 0.08 over 4. So 780,000 equals R. 1 minus 1.02 raised to the minus 60 times 1.02 divided by 0.02. So 780,000 equals R. 1 minus, let's take 1.02 and raise it to the minus 60. And that is 0.305. Okay. 0.695. 1.02. 0.02. All right, let's go up here. Finish the problem. Get 780,000 equals R. And let's just do all of these at once here. Times 1.02. Oh, we'll do it the way I usually do it. 0.709 divided by 0.02. 35.5. So R equals 780,000. $2,197. So they're looking at 2,197 over. Is that right?
I'm wondering that too. It's quarterly for 15 years.
That doesn't sound right. Let's try this again. I might have missed a 0 here.
Yeah, I was expecting over 20.
Yeah, I might have missed a 0 here. Divided by 21,971.
That
Of course.
makes more sense.
Okay. That was my fault on the calculator. So that's it. That they get every what was it?
Quarter.
Every quarter. Not bad. It's over $80,000 a year. They're lucky they had the IRA. Okay, let's do another one.
We have 5 minutes left.
Okay, number 30. Grandparents plan to open an account on their grandchild's first birthday and contribute each month until she goes to college. How much must they contribute at the end of each month at interest rate 12? This is the 12% interest rate. So we're dealing with number 30 now. And open account, so the granddaughter's first birthday, contribute each month until she goes to college. So that'll be 17 years. How much must they contribute if they want the balance to be $180,000? That's your future value. Notice, this is after 17 years. It's not at time zero. If this is they're putting this down at time zero and having it come to them, it's different. What they're doing is they're putting money on their first birthday each month till she goes to college. So, S is going to be equal to R. This is a different one now. This is a future value. So this is 180,000. 1 plus, let's see, what was our 12%? Over 12. And P is 12 times 17 years. Over
Minus 1.
minus 1. Don't forget the minus 1. If you get that, you screw it all up. So 12 into 0.12 is 0.01. 12 times 17. Okay. 204. So 180,000. Okay, 1.01 to the 204. 7.61. 0.01 equals all right, that's going to be 6.61 over 0.01. All right. I'm having trouble with my calculator because I should clear it before I do this. Divided by 0.01 equals 661. Okay, so R equals 180,000 divided by 661. $272. Sounds kind of small, isn't it?
Well, that's a car payment, you know.
That's
so
a car payment, right?
They're putting that away for 17 years every month.
Yeah, they're putting it for 17 years, only 180,000.
And at 12% interest, I mean, yeah.
And 12% interest, right?
Yeah, that sounds right.
Okay. So that's what they have to put. That's what they have to put down to get 180,000. And I guess if you assume she's going to be going for 4 years, that's going to be $45,000 a year. Well, that's probably right for most schools.
That's a good target. Yeah.
That's not a bad target.
Yeah.
How much time we have left?
We're right at 15.
Okay, we have one more session to go.
One more 15
and we'll
minutes.
be finished Thursday, quote, Wednesday's class.
All right.